OpenPLC just got a massive makeover and is officially ready for the big leagues. In this video, I will introduce you to OpenPLC, the world's first fully open source PLC software, a low-cost industrial-grade way to learn IEC 61131-3 PLC programming and prototype industrial IoT projects. But first, let's step back a bit. OpenPLC is an open-source programmable logic controller project created and maintained by the OpenPLC project. The project was designed to be a fully functional, standardized open-source PLC, enabling education, research, and low-cost automation. The editor and runtime lets you write IEC 61131-3 programs of ladder diagram, function block, instruction list, structured text, and sequential function charts that are portable to many targets. The great news: OpenPLC is dynamic, evolving, and now live in your browser as Autonomy Edge, which lets you develop, deploy, and manage automation programs from anywhere. And the IDE on your computer is now version 4.1 with a great new look. This new look marks a defining moment, establishing OpenPLC as the future of industrial automation. To get started, let's take a quick tour of the IDE by downloading it from here. Download options are available for Mac OS, Linux, and Windows. Open the IDE after completing the installation steps. From here, you can create a new project or open an existing one. I'll create a new project. Like most applications, the menu bar is located at the top with the essential commands. The activity bar on the left side of the application lets you search for text across your project. Hide or show the Project Explorer panel. Download your program. Compile and run your program. Open debugging tools and variable monitoring. And insert basic program function blocks. Next to it, you will find the Project Explorer panel. It displays the project's hierarchical structure, including programs, function blocks, functions, data types, resources, and device configuration. It also includes a library section at the bottom, providing access to standard function blocks and additional libraries you can use in your programs. The central editor area serves as the primary space for writing and editing your code. It includes a tab bar that shows all open files, making it easy to switch between them. Just below the tab bar, you will find the breadcrumb navigation, showing the current file's location in the project hierarchy. Following this is the Variables panel, presenting a tabular view of all variables defined in the current program organization unit. Then you will see either the code editor or the graphical editor, depending on the selected programming language. The graphical editor has been fully redesigned with a more polished professional look. Finally, at the bottom is the console panel, which displays runtime logs, compilation messages, and debugging information. It includes tabs for the console and search, along with a clear console button to remove all console messages. Now, I'll create a Blink variable and a new room. Drag a contact, a coil, a timer on block, and a timer off block to the room. I will negate the first and assign the Blink variable to it. I will also assign the Blink variable to the coil, 500 milliseconds to the timers. Now, head to the device configuration in the Project Explorer panel. From here, you can select the preferred microcontroller for your project, such as the ESP32, the programming port, and assign pins to the board program I/O address. You can also set up industrial communication protocols to connect with external hardware. The first time you select a board, the editor may automatically download additional tools, hardware configurations, and the required Arduino libraries. This might take a moment depending on your internet speed. And now, you can see the onboard LED blinking. If you enjoyed the video, give it a like and let me know your thoughts in the comments. Be sure to subscribe. See you again soon.